Hi, I'm George Woodbury from College of the Sequoias in Visalia, California, and in this video we're going to go over how to solve equations where the variable is the base and the exponent is rational. It's a fractional exponent. And I'm going to show you a couple of different approaches for these two problems. I think it's good to have some flexibility, some different strategies in your toolbox to know when to use each one. So I'm going to show you a couple of different ways to solve these two equations. For the first one, I've got x to the 2/3 power equals 36. And I can raise both sides to the 3/2 power. That will allow me to rewrite the left side as simply x. So if I have x to the 2/3 power and I raise that to the 3/2 power, as long as I do the same thing on the right-hand side, the two sides are still equal to each other. And 2/3 times 3/2 equals 1. So the left side simply becomes x. Now from here, I need to figure out the best way to do 36 to the 3/2 power. And I've got a couple of options. The 2 in the denominator tells me it's a square root. So I could do the square root of 36 to the 3rd power. Or I could do the square root of 36 first and raise that result to the 3rd power. And here, the second option is going to be the easier one to work on because 36 to the 3rd power is a large number, and then you've got to figure out what the square root is. You can do that with your calculator. It's not that hard. But the other one I can do without a calculator. I know the square root of 36 is 6. So because I knew that square root, by taking the square root, I'm making a smaller number to work with. I have a better chance of solving this. So I'm going to do it that way. I'm going to raise the square root of 36 to the 3rd power. I know the square root of 36 is 6, so now I have 6 to the 3rd power, and 6 to the 3rd power equals 216. Think about the way you would check this solution. If you were to put the 216 back into the original equation, would you square 216 first and then take a cube root? You would take the cube root of 216 first and then square that result. Try to pick the way that's going to be easier for you to work with. The solution set here is 216. Right. For the other one, I'm going to try it a little differently. I've got x to the 3/2 power minus 1 equals 26. And so the first thing I want to do is isolate the exponential expression. X to the 3/2 will equal 27 by adding 1 to both sides. So I know that I've got a power of 3 on the left-hand side and a root of 2, and I can get rid of those with a 3rd root, or raising something to the 2nd power. I'm going to get rid of the root first. I'm going to raise both sides to the 2nd power. That gives me x to the 3rd power equals 729. And then I can take the cube root of both sides. And remember, you don't have to take plus or minus when we're taking an odd root. That's only when we're taking an even root on both sides. The left side becomes x. Now I just have to figure out what is the cube root of 729. It's 9. Now, if we think back to the last problem, and again, I've got x to the 3/2 equals 27. If I had raised this to the 2/3 power on both sides, I would have just had x. And here, because I know the cube root of 27, it's actually going to be easier for me to take the cube root of 27 first and then square that answer. The cube root of 27 is 3, so I've got 3 squared, which equals 9. It's probably a little easier than working with the 729. But if I didn't know the cube root of 27, then maybe squaring it would make more sense first. Anyway, try to be flexible in your approach. Try to find the way that's easier for you to work it through.